What's up, guys? Today's video is on solving quadratics by factoring, and this combines solving quadratics, which we did in the last video, with what we did in a previous video, which is factoring quadratics. Okay, there's many reasons why factoring is important. As I said in the factoring video, it's incredibly important throughout the rest of this year and as you move forward in your math career that you understand how to factor. And this is just one of the reasons. That's solving by factoring it, using factoring to solve a quadratic. Okay, so I've got a couple examples here. The first one is, if you recognize it, it's a monic quadratic, which means all I need to do is think about two numbers that multiply to make 2 that add up to make 3. And I'm going to factor them like this. Because it's monic, it's going to be nice and easy. What are those two numbers? Multiply to make 2 and add up to make 3. Those numbers are 2 and 1. Okay, so that means I can factor this quadratic this way. If I were to multiply these together, I would get x squared. Then I get 2x plus x, which is 3x. And then these multiply together to make 2. So you can see very easily how that simple problem factors. Okay, well, now I've factored it, but now I need to do the solving part. Well, once you've got it factored, solving is easy. To solve this equation, there's something called the zero product property, which basically says the only way something times something else is going to equal 0 is if one of those things is 0. So either x plus 2 has to be 0 or x plus 1 has to be 0. So what could I plug in for x that would make this factor 0? If I were to plug in a negative 2 right here, I'd get 0. So x could be negative 2. Or if I were to plug in a negative 1 right here, I would get 0. And so x could be negative 1. And so those are my solutions. There's two solutions to this quadratic, negative 2 and negative 1. It's whatever you would plug in to get 0. Let's go off to the side here for a minute. Let's say I factored some problem and I came down to this. Just as an example, let's say we did all the work, we factored it, and this is what we ended up with. What would make these equal 0? Well, here you can see negative 1. A negative 1 would make this one 0. What would make this one 0? If it's not obvious for you, then what you can do is just set this part equal to 0 and solve it. Say 2x plus 3 equals 0. If I want to know when something is equal to 0, then I can set it equal to 0 and solve that equation. So I just subtract 3 on both sides and divide by 2. And I get negative 3 halves. Okay, that'd be one of my solutions. And of course, on this side, you would get negative 1. So your solutions are negative 1 and negative 3 halves. Okay. Again, if you factored and you ended up with these factors, this is how you would solve it. Okay, so let's look at this next problem. It still says solve by factoring, but that looks like a big ugly mess. There's like 5 terms there, right? Well, anytime it's set up this way and they say solve by factoring, in any kind of solving method really, whether it's a quadratic formula or whatever you're doing, we always need to combine like terms as much as possible first. And for quadratics, what that means is we really want to have a 0 on one side. So I'm going to take this stuff on the right and I'm going to move it over to the left. Okay, so I'm still going to have 4x squared. I'm going to subtract the 2x from the negative 2x that's over here already, which is negative 4x. And then I need to add 3 to the negative 6, which gives me negative 3. Okay, and now I've just got 0 over here. All right, so now I need to factor this. First of all, is a 1? No, it's not. Can I divide by 4 or factor out a 4 so that a is 1? And I can't do that either, which means this is a non-monic quadratic. Okay, so what I need to do is I need to figure out what is a times c, what's b, what's m, and what's n. And if you need to go back and watch the video on factoring, then do that. I'm going to go through a little faster because I'm assuming you know how to factor by now. If you need some help with this, go back and watch the video on factoring non-monic quadratics. All right, a times c is negative 12 and b is negative 4. Two numbers that multiply to make negative 12 that add up to make negative 4. Remember that this tells me the signs are different, okay? And then this tells me the bigger number must be negative. So think about your pairs of numbers. 1 and 12, that can't make a 4. 2 and 6, that could make a 4. And if this 6 were negative, so if I had a negative 6 and a positive 2, those would multiply to make negative 12, and they would add up to make negative 4. So that seems to work. Okay, this pair of numbers that we just had to get the signs right. All right, so then you can either just go straight to the box if you want to, and a lot of times I'll just go straight to the box. If you want to rewrite this, you can. I'm just going to go right to the box, because as we move forward with this, we need to be able to factor a little quicker. So I'm going to say 4x squared. Okay, I'm writing in this, but instead of putting a negative 4x here, I'm going to say negative 6x, and then 2x. Remember, replacing that with these two numbers, and then negative 3. Okay, so there's my middle term that got split apart into negative 6x and 2x. The greatest common factor for that top row looks like a 2x, which leaves 2x and negative 3. And if I pull out a 2x or a negative 3, either way down here I get a 1. 1 times 2x is 2x, 1 times negative 3 is negative 3. All right, and so now it's factored. Okay, so you've got 2x plus 1, and you got 2x minus 3 equals 0. Remember that it's still an equation, okay? It's still equal to 0. When we were doing factoring before, we were just factoring expressions. There was no equal sign anywhere. Because this is an equation, you got to rewrite that equal 0 each time. It is important. All right, so what would go in for x that would make this 0, and what would go in for x that would make this 0? Because those are going to be my solutions, okay? Maybe you can do this in your head. Maybe you can tell that's negative 1/2, and this is positive 3/2. But if you don't see that, we're going to write it out. I encourage you to do as much mental math as possible, as long as you're good at it and you're being careful. I'm going to subtract 1 and divide by 2. And on this side, I'm going to add 3 and divide by 2. So I have two solutions, negative 1/2 and positive 3/2.